Hey, conceptual physics students, here are some hints that might help you on the Chapter 9 textbook problems. Most of the problems of the assignment are not tremendously mathematical. They're more idea questions. And so remember that if it's a textbook problem regarding section 9.1, you can find the answer there in 9.1. That should help you a lot in working on the textbook problems. And there's a common theme on the textbook problems. These are about energy, and work and energy, remember, are nearly the same thing. Recall that work is equal to force times distance. It's a very simple formula. The work you do, or the energy that you expend, or the energy you give something, is equal to the force you apply times the distance you apply it. It is measured in joules. Okay. The abbreviation could be capital J. Joules is a unit of energy or work. Remember in class we talked about it being similar to calories. About 4 joules make 1 calorie. And another part of the chapter is this conservation of energy. Energy always stay the same. If you call the total energy TE, TE is always going to be the very same. So that means if you start a problem with a certain kind of energy, if you lose one kind, you will gain another. So I'll just give you a few hints about some of the problems. If you look at number 29, and by the way, remember that when you're working on a problem, if I gave you problems before number 29, that means that there is no hint about those problems if I don't mention it, probably because the solution is one where a hint is not required. But a few of these I'll give some hints on. So for instance, on number 29, there's something to remember about number 29, and that is speed is a part of kinetic energy. Remember, kinetic energy, the energy of motion, we'll abbreviate that KE. Speed is the biggest part of kinetic energy. Remember, kinetic energy is 1/2 mv squared. And so you can see that speed is a major part of that. So that on number 29, the idea there is regarding the total energy staying the same. Losing potential energy, gravitational potential energy. Losing gravitational potential energy always goes with an increase of kinetic energy. So if you lose potential energy, whatever you lose becomes then a gain of kinetic energy. So if you lost 300 joules, you would gain 300 joules of kinetic energy. Well, let's look now at number 32. As you look at 32, it's about pulleys. We talked in class about pulleys, done a lab even about pulleys. Okay, so remember about pulleys. You simply count the supporting ropes. And when you count the supporting ropes, that helps you determine then how much you get to decrease the force you apply to lift something up. A quick glance at number 34. 34, oops, one too many fours. Number 34, work equals force times distance. Should help you on number 34. Pretty simple. Number 37. Now, there is a section of the energy chapter that is about power. Now, power is similar to energy, similar to work, but it's how quickly you expend energy or how quickly you do work. So it's the energy that you expend divided by time. So that's also equal to the work divided by time. That should help you with the power problem that you see here. Number 39, okay? Number 39 is about this conservation of energy. Conservation of energy means that the potential energy that you have at the beginning of a problem is equal to the mass of the object, so the gravitational potential energy is the mass of the object. G, remember, is 9.8 times how high it is. So when you lift something up, you're giving it gravitational potential energy. Similar to taking a boulder and taking it to the top of the hill, you're giving it energy, and when it falls down again, it can speed up gaining kinetic energy. It should help you there. Let's take a look now at number 42. So there is something that we talk about here in this section. It is called the work energy theorem. And the work energy theorem basically says that the work you do is equal to the change, that's what this means, of the kinetic energy. So when you do work on a baseball by pushing on it, that's the same as the kinetic energy that you give the baseball. So that's number 42. That should help there. Number 50, we're almost finished with the assignment here. Number 50 is about the conservation of energy. The total energy stays the very same. You lose one kind, you gain another. The potential energy plus the kinetic energy will always be a constant. So that if the potential energy and the kinetic energy equals 1,000,000 joules, then if the potential is 500,000, then the kinetic energy will be 500,000 also. Or if the potential energy is 100,000, the kinetic energy would be 900,000. Number 51. When you lift something up, as I mentioned before, you are giving it what's called gravitational potential energy. And the formula for that is relatively simple. It's the mass times g, which you already know, times the height. So if you determine what this is, then you can do something with that information. Then the lost potential energy becomes gained kinetic energy. So if you lose potential energy and it becomes kinetic energy, let's say you lose 1,000 joules and it becomes 1,000 joules of kinetic energy. Well, if that 1,000 joules is equal to kinetic energy, then you could put this here and solve for V, enjoyable. That should help